Let me see if I can remember the proof of this. Let's just write out the sum, S. So if you think about it, I guess I'll call this a proof. If you think about it, the sum written out longhand, so I'm just talking about writing this guy out longhand. It would be, okay, S is equal to, you guys know, it's just the way I have it starting with B1, the first term positive, so it'd be B1 minus B2 plus B3 minus B4, isn't this exciting, plus, okay, dot, dot, dot. Now, depending on n, we don't know if the nth term is positive or negative, do we? So we have to include the negative 1 to the power in the nth term. So the negative 1 to the power, so it would be plus and then negative 1 to the n minus 1 bn. That's actually Sn. Does everybody see that? Yeah. That's actually Sn. Let's put in a few more terms. What? Yeah, we can do that. Just add 1 to the nth term to get the n plus first term, right? We're going to need that to prove it, the theorem. So plus negative 1, if you add n to all the n's in the nth term, what do you get? Negative 1 to the n times bn plus 1. Now add n to all the terms in the n plus first term, plus, what does that make it? Negative 1 to the n plus 1 times bn plus 2. The subscript on the b will tell you where you're at. That's the n plus second term, actually. Last one. And then we'll put a plus dot dot dot. Plus, what's the last one? Well, it's not the last one, but the last one we're going to write down explicitly. Negative 1 to the n plus 2 bn plus 3. And then there is a plus dot 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 there. I'll shrink down this statement so you can see it all. Okay, is that a big deal what I just did? I just wrote our symbolism out. Maybe it'll help you understand the symbolism and wrap your mind around it a little better. Okay, what's Sn in that statement? Sn is up to here, right? Does everybody see it? No, am I right? I'm wrong on that one. Sn is, no, I'm right. That's Sn. So Sn in this statement is up to here. So that's the nth term. That's how I know that. That's the nth term, right? Okay, well, think about what I'm trying to show. I'm trying to show this. This is what I want to show. So I'm going to take that Sn, the b1 minus b2 plus b3 minus b4 plus dot dot dot, all the way up to negative 1 to the n minus 1 bn. I'm going to take that and subtract it from both sides. I'm going to treat this like an equation. And I'm going to subtract Sn from both sides. I'm not going to write it out longhand. I'm just going to say, so subtract this guy from both sides. Then on the left-hand side, I get part of what I'm interested in, S minus Sn. And then this whole part is gone because I subtracted it out. Which leaves me with the rest of it, which is, so this is equal to what I would call the tail of the series. S minus Sn equals the tail of the series. It's also, the error, without the absolute values around it. So negative 1 to the n, bn plus 1. Let's see, plus negative 1 to the n plus 1, bn plus 2, plus negative 1 to the n plus 2, bn plus 3. I need one more. I think, yeah, one or two more. So what's the next term going to be? Even though it's not written over here, it's in the dot, dot, dot. What's the next term going to be? Negative 1 to the n plus 1, or sorry, n plus 3 rather. What's the subscript on the b? n plus 4, and then plus negative 1 to the n plus 4, bn plus 5, and then I'll put the plus dot 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 back in there. All right, I know it's like watching paint dry, but focus, shake your head, focus. Does it make sense? It's just a little bit of algebra so far, right? Not too bad. All right, now look. I can take the absolute value of both sides, right? Everybody agree with that? I'm going to do that in not this step, but the next step. In this step, I think I'd like to factor a negative 1 out of this side so that I know that the first term is positive. If I a negative 1 to the n, rather. That'll get me that the first term is positive. It'll get me just a bn plus 1 in the first term. So it's still just algebra. It just looks weird. So s minus sn equals negative 1 to the n. So imagine factoring a negative 1 to the n out of all of these terms, all of them. So that would just leave me with a bn plus 1 here, right? Which means we know now how it alternates. So it must go, in other words, I'm getting rid of the negative 1s to the power by doing this, by factoring out the negative 1 to the n. Does everybody see that? Because if that bn, so inside the parentheses, that is, if this is positive, the next one has to be negative, because negative 1 to the 1 that's left over if you factor out a negative 1 to the n. So I know now how it alternates inside the parentheses, at least. Bn plus 1 minus bn plus 2 plus bn plus 3 minus bn plus 4, and then plus bn plus 5. Proofread that for me, make sure it's alternating. It is. And then, whoops, we need actually it'd be, I guess the next term would be minus, wouldn't it? Minus dot dot dot. Okay. Everybody with me? We're almost done, I promise. Now, let's take the absolute value of both sides. We're getting closer to the statement of the alternating series estimation theorem. Let's take the absolute value of both sides. And the product here between negative 1 to the n and this guy in parentheses is multiplication. And it does turn out that absolute value splits up over multiplication and division, not over addition or subtraction. Which means I could rewrite this as negative 1, absolute value, negative 1, times this thing, the absolute value of this thing in parentheses. But the absolute value of negative 1 to the n, I should have said if I didn't say it, negative 1 to the n, absolute value of negative 1 to the n, if I pull that out, that's just 1. So that allows me to get rid of that negative 1 to the n. In other words, taking the absolute value of both sides, I could write this separately as the absolute value of negative 1 to the n times the absolute value of this stuff. But, whoops, I didn't mean that to have that extra in there. But this guy is just 1. So long story short, then, I can just rewrite this as the absolute value of bn plus 1 minus bn plus 2 plus bn plus 3 minus bn plus 4, dot, yada, 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 right? Plus bn plus 5 minus dot, dot, dot. Okay. I claim, let's see if I believe this claim. I claim that we don't need absolute values on the right side because it's a positive number. How do I know that? Well, I mean, think about it. Bn plus 1, by assumption, is bigger than bn plus 2. So what happens when you subtract bn plus 2 from bn plus 1? It's positive, right? And then you're adding in bn plus 3. That's going to keep it positive. Then you're subtracting out a smaller number. That's going to keep it positive. Then you're adding in bn plus 5, a positive number. That's going to keep it, okay, so on and so forth. So I claim that we can just drop these absolute values, make it even simpler. Okay, but remember what I'm trying to do. I'm trying to show that that left side is less than or equal to bn plus 1. So somehow I want to delete all the terms that come after bn plus 1 and be sure that we get that correct inequality. And we can do that. Here's how we can do that. So this is the last trick, and then I swear we're done. S minus Sn absolute value is equal to, I'm gonna leave this guy in front. I want this, right? Actually, I want an inequality here. But then here, look, for this guy, these two terms, I'm gonna factor out a negative rather. So factor out a negative. What's left from just these two guys if I factor out a negative? Bn plus 2. This guy changes to what? Minus Bn plus 3. Okay. And then let's do it for these two guys as well. Factor out a negative, and we'll get minus out front, right? And then we get Bn plus 4. This guy changes to minus. And then you keep doing it. Dot, 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 minus, dot, dot, dot. You keep doing that for each successive grouping of two terms. Okay. I can just make the statement. I'm going to have to convince you of this, but I can just make the statement now. With a little bit of thought, then, it's clear that this S minus Sn absolute value of that is going to be less than or equal to Bn plus 1. So I want you to think about that statement. Why can I just go there based on what I did in the previous step? So in other words, I'm deleting these guys, including the dot, 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 and saying, okay, I'm sure then what I'm left with is bigger than what I started with on the right side. If I delete all those guys, what I'm left with, Bn plus 1, is bigger than what I started with before I deleted those guys. And so we get that inequality. Do you guys see why? Well, it's because of the decreasing nature of the Bn. Look, I know that this guy is a positive number. Bn plus 2 is bigger than Bn plus 3. You're subtracting Bn plus 3 from a bigger number. It's positive, but then you're subtracting off a positive number, which makes it, from Bn plus 1, which makes it smaller. Here, same idea. This is before I erase all this stuff, in other words. This guy is a positive number, but you're subtracting it from ultimately Bn plus 1, right? Which would make it smaller if you didn't delete it. So by deleting these guys, including the dot, 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 I'm making a bigger number on the right side. Does that argument make sense? Well, then you'd have to insert that inequality to have a statement there that makes sense. So that the absolute value of S minus Sn is less than or equal to Bn plus 1. And that's it. That's the proof. Done. Am I going to ask you to memorize this? No. Am I going to ask you to understand it? Yeah. You understand these little details like the one we just went over, and that makes you better at math. Any questions on that? At this point, you're probably all, no, let's just take a break. I'm tired. I understand. I feel your pain.